3 months ago, I was sitting in a FAANG system design interview when the interviewer held up a hand, stopped me mid-sentence, and said, maybe we should switch to coding questions instead. I had spent 6 months preparing for that moment. I read the heavy textbooks, watched hours of video tutorials, and drew out standard system architectures on a whiteboard until my hand actually cramped. The problem was how I was studying. Memorizing the architecture of a massive app like Uber doesn't prepare you to reason through brand new constraints live in a room. Traditional prep teaches you what a system looks like, not how to think about it. 2 months after that disaster, I walked into 3 separate FAANG interviews and landed all 3 offers. I didn't get smarter. I abandoned the memorization routine and started using Claude as a ruthless adversarial mock interviewer. Passing these interviews requires the active defense of the engineering choices you make, not the passive recitation of textbook answers. Step 1 is problem recap. Prompt the AI to act as interviewer. Your job is clarifying questions. Take WhatsApp. Assuming permanent storage builds massive infrastructure. Clarifying messages live temporarily on the server changes your entire architecture before drawing a single line. Step 2 is capacity estimation. You state your assumptions and do the math out loud. When you slip up, the AI catches it and forces you to correct your numbers on the spot. You're calculating 4 specific variables here: daily active users, request rate, storage per request, and total bandwidth. Waving your hands at the numbers tells the interviewer you're guessing. Doing the math out loud builds immediate credibility. Step 3 is high-level design. Here, you lay out your architecture, and the AI attacks habit-driven choices. I defaulted to Postgres for a URL shortener. The AI pointed out that since reads outnumber writes, DynamoDB drops cost and latency without sacrificing performance. Finally, you hit step 4, the deep dive. You ask the AI to pick the most vulnerable part of your design and grill you on it for a full 15 minutes. When I tried to design a Twitter timeline using a poll-based fan-out, the AI made me run the queries. Realizing that pulling 100,000 posts every time someone opens the app would melt the database forced me to understand why push-based pre-computed feeds actually work. Surviving this daily gauntlet ensures you have answers formulated for the hardest edge cases before a human interviewer ever asks them. After a few weeks of this, I got a little too confident. I asked the AI to give me something completely obscure. It asked me to design a system that detects AI impersonating humans in a live chat. I had no idea how to build that. So I bluffed. I spun up vague components and hand-waved hypothetical algorithms, assuming I could slide by. The AI shut me down immediately. It pointed out that half my components had no clear function and demanded concrete algorithmic steps. The bluff completely fell apart. Faking knowledge is a massive red flag in FAANG interviews. Learning to confidently say, "I don't know," is actually a marker of a senior engineer.
Okay, picture this. 3 months ago, I'm sitting in a system design interview, my dream company, and I am bombing. Hard. I don't just mean, ooh, this is a tough one. I mean it was a full-on, stop you in your tracks disaster. The kind that makes you seriously question your entire career path. That's what the interviewer actually said to me. He just cut me off. The meeting ended pretty fast after that. I went home, sat down, and just stared at my laptop screen. I'd spent 6 solid months prepping for this. Read all the books, watched hundreds of hours of mock interviews. My whiteboards were just covered in diagrams. And for what? To get completely and totally demolished. But here's the crazy part. Just 2 months after that train wreck of an interview, I didn't just pass the system design rounds, I aced them at 3 different FAANG companies. Ended up with competitive offers from all of them. Same person, same brain, all that same knowledge from those 6 months of prep. So what was the one thing that changed? It was how I practiced. And today, I'm going to break down the exact system that took me from total failure to 3 FAANG offers.
So what was going so wrong in the first place? Well, the problem wasn't a lack of information. I had plenty of that. The problem was I had totally misunderstood what the interview was even about. It turns out the way most of us are taught to prepare for system design, it's just fundamentally broken. And this, right here, this is the whole thing. I was treating system design like a final exam. Just memorizing the perfect architecture for designing Twitter or designing Netflix from some guide. But here's the secret. The interviewer doesn't actually care if you've memorized the blueprint for WhatsApp. They want to see you think. Can you reason from the ground up on a problem you've never seen before, with weird constraints they're making up on the spot, all while talking them through it? That's the real test.
This slide just lays it out perfectly. Traditional prep, on the left, it basically gives you a library of answers. It teaches you what to say. But the second the interviewer changes one little thing, that whole script you memorized just falls apart, and you freeze. What I discovered, this AI-assisted prep on the right, it's completely different. It doesn't give you answers, it builds the mental muscles. It teaches you how to think, giving you that flexibility to adapt to whatever gets thrown at you.
For me, the game changer was when I started using a tool not as a cheat sheet, but as a mentor. A really tough one. A mentor that was relentless, demanding, and honestly brutally effective. It didn't just give me a thumbs up, it pushed back on everything. That mentor was an AI, Claude.
And this is the kind of feedback that just changes everything. I'd give my classic rehearsed answer for a URL shortener, right? Use a hash function, store it in a key value store, and instead of a gold star, I got this. It would come back with, okay, but your hashing function could have collisions. What's your plan for that? And hey, you said the system is going to be read-heavy, so why on earth did you pick a database that's optimized for writes? It forced me to actually have a reason for my choices.
And boom, that was the aha moment. I'd spent all this time learning the right answers, but had never actually understood the why behind any of them. I was picking Postgres because every video told me to, not because I'd actually thought about the read-write patterns or consistency needs of the problem right in front of me. I was just copying and pasting architectures.
So look, the huge takeaway here wasn't getting a perfect solution from an AI. The real value was in the back and forth, that constant interrogation. It made me defend every single decision, catch my own lazy thinking, and build a system from first principles based on what the problem actually needed. It didn't give me the fish. It taught me how to fish under the crazy pressure of a real interview.
Okay, so that's the big idea. But how do you actually do it? How do you use an AI to practice this way? Well, I developed this really structured 4-step framework. I did it for 1 hour every single day with my AI mentor. This is the exact process that completely rewired my brain for these interviews.
And this right here is the heart of it all. Just 1 hour a day, broken into 4 very specific parts. Each part has a goal and a strict time limit, and it's all designed to feel exactly like a real 45-minute system design interview. So let's break down what that hour actually looks like.
Here it is. We start with step 1, 5 minutes and only 5 just for clarifying what the heck we're building. Then step 2 is another crucial 5 minutes for capacity estimation. No guessing, real numbers. Next up, step 3 is 10 minutes for the high-level design, where every single choice is under the microscope. And finally, the real crucible. Step 4, a 15-minute deep dive where you get absolutely grilled on the system's weakest points. Let's dig into each one.
So for step 1, I'd start with a really specific prompt. I'd say, act as a senior staff engineer at Google. You're interviewing me. The problem is to design Instagram. Don't give me any hints. And this is so critical. The AI doesn't give me a solution. It starts asking me questions. The exact questions I'm supposed to be asking. What are the key features? Just uploads in a feed? What's the scale? 100 million users? What are the latency targets? It trains you to do the most important thing first. Actually understand and scope the problem.
All right, step 2, capacity estimation. This is where so many of us just kind of hand-wave it, but not here. I have to do all the math out loud. I'll type out my whole thought process. Okay, 50 million daily users. They upload 2 photos a day. That's 100 million writes. Average photo is 2 MB, so that's 200 terabytes of new storage every single day. And Claude checks my math in real time. The very first time I did this, I made 4 stupid math errors. It caught every single one. Let me tell you, that kind of immediate, humbling feedback makes sure you never make that mistake again.
Now we're building the thing. I'd sketch out the main components. Load balancer, web servers, database, object storage. But for every single box I drew, Claude would hit me with, why? Why a stateless API layer? What's the point? Why object storage? Why not just put the images in the database? Why 3 read replicas? Why not 5? What happens if the primary goes down? It forces you to have a solid justification for every single piece of your system. And finally, the deep dive. This is what separates the senior candidates from everybody else. My prompt is simple. Okay, now pick the most complex, most likely to fail part of my design and just drill down for 15 minutes. And it's ruthless. It'll zoom in on the news feed generation and start asking these brutal questions. How do you get the feed delivered in under 200 milliseconds? What about celebrities with millions of followers? How do you handle that fan out? What's your cache invalidation strategy? I'm telling you, it simulates the hardest part of the interview with terrifying accuracy. So what happened after 2 months of this 1-hour daily grind? What was the payoff? Well, this intense practice didn't just cram more facts into my head. It actually fixed the bad habits I'd built up over months of just passively watching videos. Like jumping to a solution before I even understood the problem, or picking a database just because it's the one I always use. Let's look at exactly what it fixed.
What I love about this is how each of these common mistakes gets demolished by a specific step in the framework. See that first one, skipping requirements? Step 1 makes that impossible. Picking tech by habit, Step 3's constant why questions beat that out of you. Faking the math on capacity, Step 2 holds you accountable in real time. And the whole thing, especially that brutal Step 4 deep dive, it forces you to stop memorizing and start reasoning from the ground up, and to actually talk about trade-offs, which is what senior engineering is all about.
And really, the proof is right there in the results. I started this whole thing being so bad at this that an interviewer literally said, "Let's just switch to coding." And just 2 months later, after practicing with an AI mentor that forced me to think instead of memorize, I was confidently leading these deep technical discussions and fielding multiple offers from the best tech companies on the planet. The system, it really worked.
So I'll just leave you with this one question. Think about how you're prepping right now. Is your study partner a passive textbook, or a YouTube playlist you're kind of hoping to absorb through osmosis? Or is it an active mentor, something that challenges you, pushes you, and forces you to really truly understand? Because that shift from passive learning to active thinking, it could be the only thing standing between where you are now and that job you've been working so hard for.